Hello, everyone, and welcome to another webinar from InduSoft Webinar Series. Today, we're going to be talking about the integration between InduSoft Web Studio and devices from Schneider Electric. So here's our agenda for today. We're going to start with a quick intro about communications with InduSoft Web Studio, how it works inside the product and the drivers. And then we're going to talk a little bit about Modbus communication, since it's a module that, or a protocol that was developed by Modicon that became a Schneider brand. We're going to talk about the Unity Pro, the SO machine, and the Triconex at the very end. And after that, we're going to do a quick discussion about main driver sheets and standard driver sheets on the drivers. We're going to talk about tag integration and drivers during this webinar. And after that, we're going to have a questions and answer. So if you have any questions, please, you can submit them at the end. I will not try to answer questions during the webinar, okay? So I want to mention to you guys, even though you may see that you're the only one logged, we have several people logged watching this webinar. That's one of the reasons why I cannot answer questions during the webinar. So please just save them to the end, and I'm going to answer all of them at the end. And then this is being recorded, so if you like it, you can watch it later. And you can share with other people that you think it is interesting. It's going to be on our website. At the end of this webinar, we're going to send you guys a survey. If you respond to the survey for us, it's going to help us improving our webinars. We're going to send you guys, as a token of appreciation, one of our T-shirts from our webinar series. Okay? So as an introduction, I wanted to let you guys know that InduSoft has been receiving several control engineering and Frost Sullivan and other awards on the latest years, and we are again running for a control engineering choice. So if you could take just a few minutes there and take a screenshot and go to our website, go to our blog, you're going to see and vote for InduSoft. We would really appreciate that. That's going to, help us a lot. Okay. So here we're talking a little bit about the connectivity that InduSoft offers. So basically, one HMI is supposed to have animations. It's supposed to show information about your field, to draw trend curves, to have an alarming system, and to animate graphics with information about your system. So all of that is going to be on the presentation level. That Web Studio has several options for presenting this value. So it can go the mobile access. The mobile access is the presentation that can go to any browser that supports HTML5, and that is Google Chrome, Safari, or even the new Microsoft Edge. So those guys, they can be on mobile devices, on PC, so it can be tablets, can be on your iPhone, on your Samsung Galaxy with Android or anything like this. So that's a way that we have to present the data. And also our website clients, or even a local viewer. So you have a machine running and you want to have a touch screen there. That's how you're going to present the data. But if you're just presenting like this, it would be just like a PowerPoint. So what we need is a way to get the data from the field devices. And that's where we have several options, including our communication drivers, that englobes also our tag integration feature, and OPC in all the different levels or layers of OPC. We have OPC UA, VA, XML, even OPC.NET. So today we're going to focus on this part here, the drivers, more specific, the ones that talk to Schneider Electric devices. So the driver module on InduSoft Web Studio works this way. Here you have your PLC. We're going to go through a communication channel. That can be an Ethernet channel, can be serial communication, or specific industrial network like CAN or controller link, device net, things like this. So you're going to go connect Modbus Plus, for example, our communication driver to the PLC. We get the bytes and bits from the PLC, we process them, and we load into tags in our tags database on the core of the product. So the core process of the product is the one who's going to spread out that information, and through TCP/IP is going, for instance, to reach the local viewer, the remote secure viewer, or any of the web client's options. So the driver here is the one getting the data and pushing the data to the tax database. You don't see the driver standing to the screens. The driver is going to push to the core process. The core process is the one who's going to distribute this information out to all the visualization modules. So talking a little bit about Modbus. Modbus is a protocol developed by a company called Modicon on the 70s, and then it was targeted directly to industrial automation, and nowadays it is managed by the Modbus organization. It's a completely open protocol. Anyone can acquire a copy of the protocol, implement. It's very easy to implement, and it's a de facto standard in the industry. Basically, it's proven how easy it is to implement and how easy it is to find devices out there that speak Modbus, all the way from RTUs to motion controllers. When you have a new PLC on the market, they may come with a proprietary PLC, a proprietary protocol, but they're going to mention we also speak some way we speak Modbus, you know. So that's why it's probably the most used industrial protocol to the date. A very simple way to address that, because it uses raw bytes with 4 types. That's and depending on how you get this this type of addresses, you can format them. So let's say you receive a register, it can be on a word, it can be a signed word, it can be a floating point, double word. You can swap the words inside the double word and swipe the bytes within a word and things like that. So there are several options. Something is going to work for your system. So talking a little bit about the Web Studio drivers that we have that speak Modbus. So through RS-232 or 485, RS-232 single point, and 485 a multi-point serial network, we have the ModBU driver for master and the ModSL driver for the slave. And we speak both the RTU and the ASCII modes on Modbus. So if you have a device, you want to speak Modbus, if you ask if InduSoft speaks that, yep. If you need a Modbus master, you're going to use the ModBU driver. Okay. If you need a Modbus slave, you're going to go to the ModSL. Then, as we go to the Ethernet drivers, we have the Modbus TCP. That's the driver that we call MOTCP. That's an implementation of Modbus that goes on the TCP port number 502, and it doesn't have the Modbus checksum. Basically, the Modbus TCP is our MOTCP driver. That's by default what to talk to most of the PLCs. But there is an option very similar called Modbus over TCP, which is the full encapsulation of the Modbus RTU into TCP/IP. Okay, that includes the Modbus checksum. And there is also the Modbus over UDP/IP, which is again an encapsulation of Modbus RTU into UDP. For these two cases here, what you use is our ModBU driver, where you go on the window that we do our encapsulation, and you configure the TCP or UDP encapsulation. So it's worth mentioning also that on the Modbus TCP, we have also the option of Modbus slave. So we can be a Modbus slave also for TCP. And finally, we get the Modbus Plus, which is more proprietary, Schneider only. Nowadays, people use the CyberLogic APIs to communicate with USB adapters from USB to Modbus Plus. For that, we have the driver called ModPL, MODPL, that use an API called MBX API from CyberLogic. Nope. These are some of the flavors that we have to use InduSoft drivers on Modbus networks. So the beauty about Modbus is that it's very simple. And on InduSoft, we make it as simple as possible to configure that. So on Modbus, when you have any addressing, any register starting with 0, that means that it's a Boolean address that you can read and write to it. If the address starts with 1, that's going to be a read-only Boolean address, binary only. So the number of zeros, let's say, or the number of digits here, it varies depending on the manufacturer. So Schneider, Modicon, old, let's say, concept PLCs, or 984 CPUs, we had only 5 digits for the addresses. Nowadays, we have some with even 7 digits on the address. Well, it starts with 0, it's going to be coil, read-write. starts with 1 is going to be input, or basically going to be a read-only, binary. If it starts with 3, then it's going to be a word. Starts with 4, there's going to be a word that you can read and write to it. And then you can get those addresses and format them in different ways. So you take 2 of these words and make it a floating point with 32 bits, or a double word, or depending on the manufacturer, they swap the little endian and the big endian thing. Okay, so you have a smaller word on the left and the red one on the right, or vice versa. So in order not to need to count this number of the number of digits, on Web Studio you configure is just the first number. So let's say 0x colon and the actual address. So for 40,001, you're going to put 4x colon 1. Here's an example of an InduSoft worksheet, the Modbus. Here I'm showing the Modbus Ethernet, MOTCP, talking to the addresses 40,001, 40,002, 40,003, and 40,004. Let's talk a little bit now about the feature that InduSoft Web Studio has called tag integration. We have just seen a little bit about the communication driver. On the previous slide, you saw that we associated tags with addresses. So we have on Web Studio a very powerful tool called the tag integration. The tag integration allows you to directly integrate tags from a third-party control application or directly from the PLC into your InduSoft Web Studio project. So you don't need to reconfigure that. All the registers that you add using the tag integration, they're going to be live. As soon as you start the runtime, you're going to start communicating. And by communicating means you're going to read constantly and you're going to write whenever the value changes on this device. And they can be used anywhere in the project. They can be used on screens, they can be used on trends, on schedulers, any place where you would use any regular tag, system tags. You can use also what we call the shared tags, or the tags that came from the tag integration. So what you do is, instead of going on the driver worksheet and manually configuring this driver, associating tag names to the I/O addresses, you can just configure where the PLC is or where the file that I'm using on my reference is, and the object finder is the one who's going to connect to this PLC or to this file and show all the available tags. So we do the configuration on the background. You select the tag from the PLC that you want to communicate with, and we're going to save that information and create a worksheet on the background. So what we do is this. During the runtime, we take all the integrated tags and we create a virtual main driver sheet. We're going to discuss the driver sheets in just a few minutes, because the main driver sheet is where you put all your addresses. As you start the runtime, the main driver sheet starts breaking into small groups on virtual reading groups, depending on the protocol limitations, the block size on each protocol, and the protocol rules. Okay? The first one that I'm going to demonstrate here is the integration that we have for the Schneider Electric Unity Pro software, or PLCs programs using Unity Pro. And that tag integration uses a communication driver called SCHNI, which is the first 5 letters of Schneider Electric. This is the driver that we use to communicate with any PLC programmable using Unity Pro software. Right now, we are validating this with Unity Pro version 8. We know that version 10 is out, and we are already getting ready to validate it with Unity Pro 10. But as of now, we have only Unity Pro 8. And what it does, it wraps the addresses that you configure on Unity Pro into the regular Modbus protocol. This software is the one used to communicate with M340s, M580s. The star here is just because I don't have one 580 here in the office or in our lab to validate that against 580 yet. And we have the premium PLCs and the quantum PLCs. So when you use to program the PLC using, let's say, concept software, when you have the 984 or you have the Telemecanique or the Tweedle PLCs, to program these guys, you use the Unity Pro software. This driver, the SCHNI driver, supports two addresses only, which are the %M, those are the binary addresses, and the %MW. Those are the word or analog with formats in different options like floating, double words, and words, as you're going to see pretty soon. So that's the driver that's going to run behind the tag integration to Schneider. So on Unity, when you open that software, you're going to see that there is an addressing method, and there are three ways, depending on the PLC, that you can address one I/O address. For example, if we choose a channel thermocouple module that we put on our hardware, that we mount on the slot number 5, and we say that the input address is going to start on the address 201. So it's an input 201. So the flat address would be %IW201, like this. And I want to address specifically the channel 3. Out of these 8 channels, starting on 201, I want to address the channel 3. So the 3 addressing modes that we have on Unity Pro are flat, that would be %, % to call any address, IW, input, word, 203, so 201, offset 3. That's how it works for the quantum PLCs, for instance. That's a flat communication. But the M340s, for instance, they use the topological address where you put %I1 dot the slot number 5 dot the channel number 3. Okay? And using the regular Modbus, or what we call the concept addressing, that's going to be, it's going to start with 3 because that is an input. It's going to be 30,000, 203. So you have the offset against the 201 from the start input address. So out of these 3 options, our SCHNI driver supports only the flat addressing, which is the type of addressing supported by the regular Modbus protocol. We are working on implementing also topological addresses, and that's on the works. But what I have to show you guys now is how you work with what we have, which is the flat addressing. And for that, we're going to show the M340. Here I have a screenshot of the hardware configuration. So I add here on my PLC one analog input module, and I configure that as used. So it shows here on my variable table. It shows as integer, 32 bits or 16 bits, and is a %IW0 because it goes on the slot 0, .2, .0. So that's the channel 0. Here, channel 1. So this is something that the driver SCHNI doesn't support yet. Okay, that's just to make sure that I point out some of the limitations, but we're going to see that at work, so we're going to see how that works. Okay, so let's talk about the tag integration that uses the SCHNI driver that has been developed by InduSoft Web Studio to communicate with those PLCs using the Unity Pro software. So the tag integration, what you do is, on the PLC programming software, you're going to export the variables that you have created and assign it addresses that are on the flat mode. You're going to export these variables to an XSY file. And on Web Studio, you're going to import only the tag that you want using our tag integration tool. So how we do that? You go on Unity Pro, find your variables, and right-click and click on the Export button. As you export this, you're going to have this window where you can enter the name of the file that you're exporting. And on Web Studio, when you're configuring the tag integration, you enter M340, that's the platform, the IP address of the PLC, and you're going to enter the XSY file that you have exported. So first you export, and then you browse where the file is, and that's how you have created this connection. Okay, so what you have to do when you're configuring those variables for them to be available for Web Studio? First, you're going to configure a %m EBOL or a bit from a word like this, %m100.3. These two addressing types work with our tag integration and with our driver. And keep in mind that %mw is pretty much the 4x equivalent of Modbus 4x area. And the format of this is going to happen on the driver itself. So using tag integration, you don't have to worry about the formatting. But here we are showing that on Unity Pro, on the type, you have different formats. So let's say here the %mw1000 is the type of real. So on Web Studio, what we do is we configure as %mf1000. That's how we communicate with this variable here. But this is only if we are addressing directly the variables here using tag integration. You don't have to do that. So let's go to a quick demonstration now on how that would work. So here I'm going to open to you guys. This is the Unity Pro software. Okay, so the data editor opens when we come here and we open the elementary variables. Those are the variables that we have created. Then what I have to do is I'm going to export those variables. So I'm going to export. So I'm going to put on my desktop here, and I call this Webinar 2. So the file is called webinar2.xsy, and it's going to be here on my desktop. That's the file that I'm going to use on my Web Studio project to communicate with the addresses on this PLC. So then on InduSoft Web Studio, let's start a new project. So it's going to be my Webinar 2. We just had one webinar in the morning. Okay, so why it creates the project, one thing that I want to mention is I have exported that file to my desktop here. So ideally, that file should be on the project folder. So I'm going to just add that file to our project folder. Why? Because I'm going to need this file both during my development and during the runtime. So if I copy this project to a different machine and I forget to copy the XSY file, the driver is going to fail. The driver requires that file. The driver requires that file during the runtime as well. Okay. So instead of going here to the communication drivers, associating things, what I'm going to do is simply go to Project, Communication, and here on the tag integration, I'm going to add a new data source that I'm going to call M340. And that is going to use as a provider the Schneider Unity Modbus. So I'm going to enter the PLC IP address. And I'm going to look for my XSY file here, which is on my project root directory here. What will be this HMI only? When I'm configuring Unity Pro, I can check one box there saying that it is an HMI. So that's going to help me filtering the files, the tags are going to be showing when I'm browsing for tags inside the PLC. Okay. All right. So I have configured the tag integration data source. So what I can do is I'm going to go to a screen. I'm going to create a screen here. And as a first example, I'm going to just simply put a text box. And on this text box, I'm going to put one of the tags from the PLC. So here I'm showing the devices that I have. And for whatever reason, it's not showing my tags here. So let me go back here on the Unity Pro. I have my variables. And let me export. Oh, no, it is showing there. I know what I did wrong. So double click here. Double click here. I had this box checked here, show all imported tags. We haven't imported anything yet. There you go. Now I have here all my tags. So I have some tags on Unity Pro that are changing the value constantly, because on my ladder logic, we created here a timer, and it's going to be feeding. See, we have some timers changing values. So on this table, I can see some of the tags that are changing. So I'm going to go and import the timer on delay 1.acc. It's going to be easy to see the value changing. So timer on delay 1.acc. That's how we communicate. So besides this, I'm going to put also one of our symbols. So I'm going to go here on symbols. Symbols, so let me pick one. Let's get the meters. This health round, I'm going to insert here. Okay, I know that I go from 0 to 15,000. And the tag that I'm going to put here is going to be the one that you have just imported, the timer on delay. Okay, I'm going to save my screen. It's going to be my main screen. And I'm going to configure my viewer module in a way that I can move that around so we can see both the screen and the PLC at the same time. Okay, so I'm going to start my runtime. And I'm going to move to this screen here. Where here I can resize. And let's compare this side by side with Unity Pro. There you go. You can see here the timer 1 accumulator. So if I write 0, it starts all over again. That's the one that I'm communicating with. So if I'm going to add another one, so I'm going to add, for instance, the timer 1 accumulator. So I go here on my screen, timer 1, no, the timer 5. And I'm going to put another object. I'm going to put, for example, a rectangle. And I'm going to add a bar graph animation. Double click here. Let me show all the tags. And here is my timer 5 accumulator. Good. And I can show our blinking. So if I put here ellipse, and I'm going to add a color change, I'm going to pick the bull blink tag. You can see how quick it is to connect to a tag from the PLC. Right? I'm going to save. I didn't even stop the runtime. The runtime was still running here, and everything is still communicating. So what happened on tag integration is that we are creating on the background a main driver sheet. You don't see that, so if you try to configure the driver here, you're going to see that we don't have anything to be configured. So at the end, you're going to show some hints that you can have to optimize this communication. That can be even faster than what we're seeing here. Okay, so if you like this or if you have questions about this, we're going to answer them at the very end. So let me stop here and go back now to the presentation where we're going to show a little bit now about the SO machine. So the SO machine is the software that is used to configure devices from Schneider Electric, such as the M241s, M251s, M221s, their motion drivers. Here I put the PAC Drive 3 or the LMC 600, which is actually the same thing, and any other device that is from the SO machine or SOMA, how some say, the SOMA family of devices. The way it works is that we wrote a driver for Codesys, and Codesys is the core that runs in all these devices. The PLC part of all these devices is Codesys. And Codesys has one library called PLC Handler. So we programmed our Codesys driver to use this API from 3S, the makers of Codesys, called PLC Handler. And through the PLC Handler, we get to the Codesys runtime that is going to be running actually inside. On this picture here is a M251. This also works with any other device that runs Codesys. So it could be this Eaton PLC here, it could be a Wago PLC, Bosch Rexroth. So anything that runs Codesys, you can use this driver to do that. And this shows how reliable that platform is. So the good thing is that on the Schneider Electric SOMA family of devices, it runs Codesys. So how did we implement that? So we implemented what we call the RT3 implementation. So it's the RT3. There are different things that you can do with Codesys. So we do also gateway. We can go to a specific gateway port. We can go to Codesys 2. But to talk to SO machine devices, basically the best option is RT3. We access the variable directly on the PLC. So let's say you program, you download your control part to the PLC. We can go read the PLC tags directly from the PLC. What if the PLC is offline? We can also use the symbol exported by SO machine. So we can read the symbols also, so you can configure them, and during the runtime, that's when you're going to go and communicate with the PLC online. So note, it's mandatory when you're configuring your projects to configure a symbol configuration on your SO machine project, okay? So when you're configuring the project, you're going to create variables, you have to add a symbol configuration, and that's for anything using PLC Handler. It's not only on the case of InduSoft with SO machine. If you're using PLC Handler or OPC server to use Codesys, you always have to have the symbol configuration. And to add the symbol configuration, what you do on your process, on your project, you right-click, add object, and you're going to find the option to insert a symbol configuration to your Codesys project. In this case, the Codesys that runs inside the SO machine. Again, on the tag integration, it's very simple. The configuration is you add a tag integration source specifically for Codesys. You're going to select the runtime version as Codesys 3, and you're going to have a field that is the runtime address. On that, you're going to configure the PLC node name. So that's the part that is a little bit different depending on which Codesys flavor you're using. On the case of the SO machine, where you can find that? Here's a screenshot of a SO machine. In this case, it shows all the PLCs that we have on this network. And the information that you have there is the connection type, the controller, the type of controller that you're connecting to, and the IP address, for example. But the most important thing here is the node name. So here I'm showing I have selected this TM251 MESC space at 0080, etc. So that's the guy that you're going to enter on the runtime name on InduSoft Web Studio tag integration. So here is a window to configure the Codesys tag integration. You go, you add the source, choose Codesys 3, add the runtime address, and click OK. That's it. We're going to browse the tags directly from the PLC. If you want to browse the tags offline, let's say that you will not have the PLC available all the time, all you need is the symbol file exported by Codesys. That's it. It's an XML file. We just point here where this file is going to be. As simple as that. So again, you pick the node name, and that's what you're going to put on the runtime address field. That's all. Quite simple, right? So let's do a small demonstration on how that works. So what I'm showing to you guys now here is the software SO machine. So let me go offline. I have already configured this project here. So here I'm okay. So here I have the application tree view, the devices tree. So here I can show all the controllers that I have on my network. So let me open here. So now I'm scanning all my network. And I'm going to pick here. This is the one that I'm going to talk to you. It has my project called Webinar Test, my M251, and here it shows the node name of that PLC. So I'm going to need that information. So let me go here and copy this, so I don't have to memorize and type all that. Then I'm going to go on my Web Studio, and I'm going to create a new communication tag integration. I'm going to add a Codesys. And this Codesys is going to be my PLC model M251. I can put here anything that I want. I'm just calling for the same model as the PLC. And then I choose Codesys 3, and I enter that runtime address that I have copied. And that's it. OK. And OK. So just like with the M340s, let's go here and add the text box and add some of the variables that we have on Codesys. So differently than the M340, on Codesys, I'm reading the variable names coming from the PLC. So I have a couple of global variables that I have created on the PLC and a couple of local variables. So let me go here and get this here called local test. And I'm going to add a checkbox for the Boolean one, which is this. You can see the icon here says Boolean, the local test one. Because of the logic that I have on the PLC, whenever I enable this, I'm going to have the other tag counting up. So I'm going to enable that using a checkbox. I'm going to even change this checkbox to be a push-like checkbox. So we can see, I'm going to remove the focus, so we can see this either pressed or depressed, and that's going to enable counting up or down. So I'm going to save this, And as I call the runtime, I'm going to bring here the runtime. It is initializing, and here I can see the Codesys value counting up. So which values do I have on the PLC? So I'm going to go here on SO machine under Applications Tree, and I'm going to bring this POU that I wrote here, and I'm going to go online. And I'm online. So here are the values. When I compare them with my Web Studio runtime, so I'm going to click here, I'm going to check, I'm going to change this local test to false. There you go. I stop it counting up. And I'm going to write another value here. There you go. And I click check. Now we are counting up again. It is that simple. I read the variable names directly from the PLC, but directly on my object. I didn't have to configure our drivers or anything like that. That's the beauty of the tag integration. Can we speed up the communication? Yes, we can speed up the communication. Can we debug this on different ways? Yes, and that's what I'm going to show when we get more towards the end of the webinar, okay, in just a few minutes. So again, what we do is we create a main driver sheet on the background. That's the tag integration. If I'm running and I want to add other variables, it's just like we did with the M340. I can go and add here. I didn't stop the runtime. The runtime is still running. I'm going to browse, choose one of the global variables. So I'm going to pick my temperature T1. Click OK. I save. Here my runtime is already blinking. And here I have the values. You can see the temperature one there. Let's see if I can write 0 to this. Okay, you see it's counting up again. Simple enough, right? Okay, so next, there is one other PLC that I'm going to talk to you guys about, which is the Triconex PLC. What is a Triconex PLC? This is a triple redundant safety PLC that was from Invensys, and once Invensys became Schneider Electric, and we became also Schneider Electric, it all became the product from everybody from the same family. It has a built-in OPC UA server on it. And since InduSoft Web Studio has OPC UA client on any of our runtimes on PC, on Windows CE, you can also use the OPC UA to talk to those PLCs, Triconex PLCs. But besides the OPC, we have also our TSAA driver. That's a communication driver built in on Web Studio that communicates with Triconex PLCs. As you're going to see, if you're familiar with Triconex, you'll see that the addressing method is very similar to the one of Modbus. Here's a screenshot of that and some information. So the Triconex driver right now doesn't have a tag integration. So what I have to do is to configure the driver just like we always do with any other driver that doesn't have tag integration. And it supports the standard driver sheet only, no main driver sheet for Triconex driver, the TSAA. And we communicate with the alias numbers, these numbers here. Those are the ones that we communicate with. So when you are configuring a TSAA PLC and going to have InduSoft Web Studio communicate with it, as you declare the variables, you have to declare the alias number following the same rules that you follow with Modbus. So on a quick demonstration, I'm going to connect to one of my machines here where I do have the Triconex programming software called TriStation 1131. So it has a few programs running there, and if you open here any of the variables that we have configured, this is an alias, or I could enable read alias, or I would, change and put another alias. So let me open here a window where you can see a tabular view of all the variables. There you go. So if I scroll down here, I see that some of the variables are read-only, others are read and write, because some start with 30,000, others start with 40,000. Okay, so in this area, I will have some of the tags that I want to show the value. So here I have my analog 1 HAL that has the value of 555. Can barely see it. It has the alias address 41003. That's the value that we have here. So that means this guy is read and write. So switching screens here. This is analog 10. As I go to analog 1, here, 41003. And here I have a tag which is on 33003. Okay, so what we have to configure to talk to some of these guys? It's very simple. On InduSoft Web Studio, we're going to go here on the drivers, and we're going to add on our project the TSAA driver. So here I'm going to select which PLC type I'm going to talk to. This one that I have is the Trident with symbol table. And then I'm going to right-click and insert a driver worksheet. So that's the standard driver sheet where we have full control of our communications, full feedback of our communications. So we're going to be talking to the 3X addresses first. On the IP 10.13.63.19, on the ID number 1, and I'm going to put here on my header 3X. So I'm going to put here my tag analog 1. It's going to be a floating point, and that guy is on the address 33001. So here I have the first 3, and here I'm going to put 3001. The analog 2 is another real tag that's going to reside on 3002. So it's 33002. And I'm going to read that every second. And that's a read-only type. So I'm going to create another TSAA address. They're also going to read every second. That's going to go to the 4X. And they station the same one. And the address here is going to be what was my analog 1 high alarm limit. The address, this is 41,003. Okay, so to check the value of these tags, I'm going to put analog 1, analog 2, and this other guy here, I'm going to put here on the database PI. And I know that on the Trident here, for that specific variable that we can read and write, we have the value 555 here. It's kind of hard to see. So now it's even harder. There you go. Here's the value 555. So when I go on Web Studio and try to talk to this variable, which will be this one here, analog 1, how? So I start the runtime. And the communications are starting. There we go. We got our 555 here. I don't know if the rest of the runtime is actually here on the other screen. Here I'm talking to the Codesys that runs on the M251. Here I'm talking to the M340 using the accessY file. And if I write here, for instance, if I write 4444, I'm writing to the Trident. Well, it overrode it because I didn't enable writing here. So let me enable writing. Let me try to write now. Let me see if that goes. So I wrote it, but I don't think I can see. Yes, here we go. We can see that here. I wrote this value to the Trident PLC. Okay, I just don't know how to force here on the Trident. I really don't. Even though I enable here setting a value, it's not allowing me. So I'm not that fluent on Triconex yet. So that's why I could not write anything. But you could see the bidirectional communication happening. And that's what I wanted to talk to you guys about Triconex. There are OPC servers available for Triconex PLCs. There are DDE servers, even OPC UA. Just keep in mind, depending on the project, mainly if you're going to go on an embedded system, it would be hard to install some of these features. So you can use InduSoft Web Studio with our TSAA driver on those systems as well. So now a quick discussion about main driver sheets and standard driver sheets. What you have just seen with the TSAA driver was an example of a standard driver sheet. The main driver sheet is the following. You have one worksheet where you configure all the addresses. Very simple to be configured. And you don't have to think about block sizes or limitations of the protocol. Just put the Web Studio tag, station, and IO address. And you configure when you're going to read this, if it's always or only when that guy's on the screen, and if you're going to read, write, or both on this tag. And the cons is that, as you saw, the communication happens every 600 milliseconds to all the groups. Can you change that, customize that? Yes, you can, but always going to be the same reading rate to all the groups. You cannot have a group reading faster than the other one. And it's a little bit hard to identify which group is actually failing. You have some tags working well, some other tags with bad quality. Which group's causing that? Because sometimes one bad tag can cause a whole group to go bad. Okay, so we have some hints on how to do that. And it writes only by item. We don't have any group writing, which means we cannot write, let's say, 100 addresses just at once, at one shot. So on the main driver sheet, here are some troubleshooting hints. First, you can see the groups that were created by the main driver sheets, the virtual groups. You can export them into a very similar format of the standard driver sheet. So you can go and open these files and actually see the groups. All you have to do is you open the project APP file. Every project on Web Studio has this file with this extension. Open this file using a text editor. And then you're going to find a section called Options, where you're going to add this entry here, dump driver sheets equals 1. When you save, open the project again, run the runtime, you're going to see that all the driver sheets that, all the groups, virtual groups, are going to be dumped into driver sheets on the project's web dump folder. Then you can go back in development and use the open file command to visualize these files that were dumped or exported. And the optimization hint is you can change the reading rates of the main driver sheet. Again, you just open the app file using a text editor, go on Options, and type main DRV always trigger, and you put a tag name. So right now, we are reading every 600 milliseconds. So we have an internal tag called blink fast that reads every 200 milliseconds. Or you can create your own. Save and run the project. So in this example here, in this project we are doing, if I go here and open the app file, so I'm going to open this guy using Notepad, and I'm going to find a section called Options. Here, I can add main DRV sheet trigger, all right? I guess that's our entry. Main DRV always trigger. So main DRV always trigger. And I'm going to put here the tag, the internal tag called blink fast. And also I'm going to create the entry that says dump driver sheets. I'm going to make it equals 1. Save this file. And I'm going to reopen my project. And let me go to the project folder here. Database Spice, a beauty. I can run any function, force values, everything. So I'm going to call the runtime. I haven't actually configured startup screen, so let me call again the runtime. Okay. So the runtime is running, and now I'm going to go using Windows Explorer to the project folder. Here on the project folder, we're going to look on the web, dump, and see. We have here this DRV files. Those are the files created using that driver sheet, the dump driver sheets. So I can go here on Web Studio, File, Open Project File, and then I'm going to change this to drivers or any web dump. So I'm going to pick here the Schneider driver. That's how we configure our driver sheet, so I know which tags is where. You can see the station, what we do. Here's the XSY file, the PLC type, IP address, all the things. All right, and let's check the runtime, the reading speed. Oh, it's much faster now because we are reading every 200 milliseconds now. So we are reading 5 times per second because I changed it, the trigger to be blink fast. Here, I changed to blink fast. So on the TSAA, for instance, we use the standard driver sheet because we don't have the option. The other drivers, we do have the options for main or standard, but not all the drivers have the main driver sheet. So you have to use a standard. Some of the pros of the main driver sheet is that you have full control of your communication. You can read as fast as possible or on demand using the read trigger. You can write an entire group using our write trigger. So a single shot, we write all the tags that are on that group. That's great for transferring recipes, for instance, for the PLC. And we have the individual group feedback. So we know when a group just finished reading, and we know the status, if the communication status is good or if we have bad on that specific group. And you only configure the station field once for the entire group. The cons. The configuration is less friendly than main driver sheet because you have full control, you have more things to configure. There is a manual configuration obeying the block sizes. On Modbus, you can go usually up to 125 words per block. So you have to keep that in mind when you're configuring each main driver sheet. You're going to have 125 words from the PLC, okay? And you configure only one station per worksheet and only one register type. That means if I want to talk to the 4X and to the 3X, I have to have two different worksheets. And because of the block size, if I want to talk to the 4X, or let's say 40,100 and 40,300, there's a gap of 200 words there. I may need to have two driver sheets. This may cause you to end up using several worksheets, which is harder to maintain. So, thank you. And now I'm going to open for our Q&A. So you may submit your questions here to our Q&A, either through the chat or on the Q&A panel. Depending on the question, I'm going to either answer privately, or if I think it's a question that makes sense to be shared with everybody, I'm going to read the question and respond to everybody. Okay, so a question that I got here is related to the Schneider driver, the Schneider driver. And the question is, can we communicate with the actual addresses? So on the driver itself, yes. So when I open here, the Unity Pro, here we have, on the data editor, the actual address of each one of those devices. Let's just wait here until it shows. There we go. So here are the actual addresses. So for instance, I have here the timer 1 ACC with the address 502. So on Web Studio, I could go here and configure the Schneider driver to talk to that PLC. So I'm going to call here my timer 1 ACC. So I'm creating a tag. And I go on the PLC. I enter here the IP address of the PLC and the slave ID number. And I'm going to put the same way as I have on the PLC, %MW 502. So if I'm going to here check the value of this tag on the database by, you see, it's counting up. That's the same value as on the integrated tag that we imported called timer 1 ACC. Here. They're reading from the same place in two different ways. And talking about different ways, since this is a Schneider PLC, it speaks Modbus. And the relationship between the %M and the concept address is very simple. So let me add here the Modbus driver, Modbus Ethernet driver. I'm going to go to the same PLC. So MOTCP, I'm going to put here. Going to be my timer 1 ACC using the MOTCP driver. I'm going to go on the station 10.13.63.99, my IP address. And the address is going to be 4X:503. Why is that? It's because on the Schneider driver, we go on the %M that starts in 0. That's 0 base address. The 4X addresses, it starts in 1. So there's always going to be that small shift. So if I start the runtime again, so I start the Modbus driver, when I put this address, oops, wrong addressing. There you go. And we are all talking to the same address, which is the timer 1. Okay. Okay, I got a good question here. What is better, a big block size and few standard driver sheets, or small block size and a lot of driver sheets? So think about this. If you have only one standard driver sheet with 100 addresses, or 50 driver sheets with one address on each, or let's say 2 addresses on each. Each one of these messages that we are sending to the PLC, they take time. If I enable here on the output window, so let me bring the database file back here. So I'm going to enable log in my communication, and you see a lot happening here. So each driver sheet is going to have one of these messages that's being sent to the PLC. One TX message and one RX message back from the PLC. The problem here is that it takes much longer to prepare the entire message and send than it takes to send a longer message. So if the question is, should we have less worksheets with more addresses or more worksheets with less addresses on each? The answer is definitely less worksheets. The less worksheets that you have, the better your communication is going to be. Thanks for the question. Okay, so I responded another question here privately. And we passed a little bit over an hour. So I don't see any other question here that would be worth responding to everybody. So in this case, let me show you guys how to contact InduSoft. Here's our general email, info@indusoft.com. If there's anything on this website that interested you, that you want to learn more, please send us an email, info@indusoft.com, and then we can respond to you, answering any questions that you may have. Or you may call us, you may visit our websites. We have websites in the United States here. In Brazil, we have the website in Portuguese, and in Germany, our website in German. You have the 3 phone numbers for each one of our offices. So US, Brazil for Latin America, and Germany for Europe. Here in the US, we have our toll-free number, 877-InduSoft. And here's our fax information as well. So with this, I would like to thank you for your time. Thank you for this opportunity to present this InduSoft Web Studio solution for Schneider PLCs. And again, if you could go ahead and vote for us on the control engineering. If you don't know exactly how to vote, go to our website, go to our blogs. We have all of our information there on our website to help you voting for us on the control engineering. And if you fill out the survey that we're going to send to you guys, we're also going to ship to your direction one of our T-shirts for the webinar series. So thank you very much, and I hope to see you again on future webinars. Have a great rest of your day.